I'm Robin Cole, and welcome to the Satellite Image Deep Learning Podcast. In this episode, I caught up with Daniele Rege Cambrin, the organiser of the SMAC Earthquake Detection Challenge, and Giorgio Morales, its winner. The challenge invited participants to leverage Sentinel-1 satellite imagery to identify earthquake-affected areas and measure the strength of events while promoting scalable and resource-efficient solutions. Giorgio shared his innovative approach that secured first place, and we explored the effort behind designing and solving such a meaningful challenge. This conversation provides valuable insights into developing effective solutions and showcases the potential of satellite data in earthquake monitoring. If you're watching this on YouTube, please consider liking the video and subscribing to the channel, as this really helps to reach a wider audience. Thank you. Hi, gentlemen. Welcome to the podcast. Daniele, great to have you back on the podcast. And Giorgio, welcome for the first time.
Thanks again for having me.
Yes, Daniele, let's begin with you. How about you give us an overview of how the competition went?
Yeah, thanks for also the invitation again. And I will try to give you an overview. So there are also some other people that taken part other than Giorgio, for sure. That was our winner. So in the competition, we asked the people to investigate if it's possible to understand the magnitude of the earthquakes and also if area was affected by some certain, seismic activity. Just to, foster. Some people ask me when in a conference, what is the purpose of this? So my answer to this is, with this, we can simply try to help people that are, domain experts to investigate with finer granularity the area of interest, because, scraping all around the globe for seismic activity is quite, a big issue. So if we can try to understand which area are the most interesting for the people that are domain experts, is for sure a good way to improve our analysis, and is also improve the fastening the procedure, I would say. So in the competition, we asked people to detect the magnitude and also, as I mentioned before, if an area was affected, with some imagery taken from a satellite that is Sentinel-1, so from radar imagery. So, they are quite, I would say, reliable every day, every night, in any condition. So they can easily deploy it in any situation. Also, they mentioned that nowadays many people are using radar, low-cost radar, to monitor other things. They are launching many of these, so they for sure are quite low-cost things that could be, deployed and used for collecting data. So we collected, I would say, like 20, 30 participants, more or less. Some people have, quitted during the competition because everyone is doing, I would say, for the sake of the competition and for curiosity mainly. This year was like the previous year for the other competition. So I would say the numbers for these topics, so related to remote sensing, observation, crisis management, etc. We in this conference, I would like that is ECML are like 30 people, more or less. Then I would say that at the end, 5-7 people reached, I would say, the last phase. So they have their own solution that could work. With respect to the previous year, what I noticed that all the people stick with my data. The last year, some people have tried to do some pre-training, use external data, publicly available data for sure. Also this year, we tried to use this constraint because we don't want people to use some commercial data or other things like that to limit the reproducibility. And we asked them to also share their solution with people, because we have to learn, at least it's a competition. And so this is what is the purpose of this, I would say. So from this year, I would say we have collected many people that are more expert in this, like Giorgio and other participants worked many times with Sentinel-1, radiometric imagery. So they provided us with a more expertise. I would say that I'm a more general purpose investigator, mainly computer science oriented, I would say. So that's also the objective was, I would say, these competitions also try to collect people from different expertise, from different, I would say, fields also, if possible, and try to gain the collect them to investigate these possibilities because we need them. And also it's like, an emerging field. So we need people with different expertise from not only computer engineering, from, in this case, geophysical, I would say, background, but also, as you are one of them, from probably physics field, etc. So that's good to have other people that are expert in other things. So they can also try to understand if there are some issues, I would say, with the data. But because at the first time, when you provide the data, when you work with the data, you try to focus on certain aspects because you don't really know exactly what you are doing. So it's important, I would say, to let other people that are not biased in some sense, I would say, by what you have done, to understand exactly if there are some issues, some flaws, if there are some better way to evaluate the problem, if the problem is even better solvable, like this is the point of the competition. If there are better solution, easier solution. There are also, many other competition around, like in other conferences, also like, other workshops that are tailored for competition, like Semeval, for example, I mind, or Trek, that is like for 20 years right now that they do this. Is like simply providing solution that works for, people and also research, because sometimes we still focus on providing something new, but they works probably sometimes worse than previous solution. That's the problem. Sometimes we simply lose our focus as a researcher, I would say. Probably in industries like different, but yeah, that's my view, I would say, of the whole competition. I don't know if I missed something, probably, but.
Thank you. Yeah, I mean, I agree. It's a very interesting field to work in, just because you have all these people coming from different backgrounds and contributing together, some working on these problems for the first time, some with deep domain expertise. On that point, it'd be great to hand over to Giorgio and hear about how you tackled this challenge.
Yeah, thank you for the invitation. Thank you, Daniele, for organizing this competition. Probably I would like to start saying that in this type of competitions, when you receive the data, one tends to use basically a very common approach, like you training a neural network or a convolutional neural network in this case, that hopefully is going to capture the complexity of the data or that kind of thing. But I guess my approach was a little bit different this time, because I noticed that when the data was given, I mean, just to give a little bit of context, we are given images that correspond to the pre-event, and another image, and another corresponding image that corresponds to the post-event. So basically, the task is to compare these two images, and for the first challenge is to detect if there was an earthquake or not. And well, the second one is to calculate if there was an earthquake, what was the magnitude. But just for the sake of comparison, what I started doing was to actually compare pixel per pixel. And it was very suspiciously easy when it comes to compare pixel to pixel, because for the case of events in which there was no earthquake, basically the pixels were exactly the same. I mean, the backscattering coefficients for the VV image, which basically is the image that sends a signal with a vertical filter and receives the signals with the same kind of filter. That's one band of the image, and the other one is it sends the signal with vertical filter and receives it with horizontal filter. So we have an image with two bands. So there was no change for at least one of them. And I think that the main reason is that the images were captured within a very short period of time. Maybe I have to say something about that later, but basically that was the main approach. Counting the number of pixels or the ratio of pixels in the image that did not present any kind of change, that was the main classifier. And the only hyperparameter that I decided to use was the threshold of this ratio. So if this ratio is greater than, say, epsilon, then we can say that there was or there was not an earthquake event. So that basically gave me or allowed me to obtain, I think, almost 99 of F1 score in the training set. But it was very interesting to see that there was no false negative. There was only false positives, 8 false positives in particular. And those cases corresponded to what I suspect it was images of the shore. So basically images of the sea. And you could see the shapes of the waves and everything. So, of course, if there was earthquake or not earthquake, there's always going to be a change. So I think it makes sense. And I guess one critique about my approach is that it's basically a change detection in general. It works for the purpose of the competition, but it doesn't mean that we now have are able to collect the representation of or the knowledge to discern between what is change that corresponds specifically to earthquake or change that correspond to fires or something like that. Mm-hmm. So for the purpose of the competition, it works. And that was the first task. The second task was the magnitude estimation. And for that particular case, I tried in the beginning to use some kind of regression models, again, neural network-based models in the beginning. But I noticed that every different type of technique that I decided to use was leading to the same kind of error. So basically, I combine all the information from the training set, validation set. I perform cross-validation, and I noticed that it didn't matter what kind of class or regression model I decided to use. The error or the accuracy was not statistically significant. So one of the conclusions that I arrived is that basically we don't have enough information to understand or estimate the magnitude of the earthquake. So conceptually, I think that's one of the results of the competition, to understand that given one image from before and an image from after is not enough in itself to estimate the magnitude. Say, for example, if we are located at one specific point where is the hypercenter?
Epicenter, the one at the at the surface. The epicenter is one in the in the bottom, inside the heart.
Yeah. So okay, for my example, let's say epicenter in that case. So let's suppose that we are located at the epicenter. The magnitude or the effects that correspond to the surrounding area are in an event, let's say, of a magnitude 7. The effects are going to be very noticeable around that area. But if we move away, let's say 5 kilometers, the effects are going to be different. So if we only have the images without knowing in which specific point we are, it's not going to be enough. And so that's the first observation. At the minimum, we will need to know what's the distance with respect to the epicenter. And second one, if we repeat that same example and we imagine that we are in the desert, the effects are going to be different because of the soil properties and, basically soil properties, I guess. But if we repeat the example in the mountains, the effect is also going to be different. So we will also need to have access to the information about soil types, environmental conditions, and so on. So I guess that's something that as I said, it's something that we learned from the competition. And something else, another observation is that probably it's going to be a mistake for future approaches to try to gather or collect all the images that correspond to earthquakes from all around the world and try to train a single model. Basically, because of the same reason that I said before, like, and I think in the report I mentioned something similar happens in precision agriculture, because normally when you study one crop, let's say corn, these crops don't behave the same in different parts of the world, not even within the same regions. So one usually tends to train a model that is specific to each farm or each field, just to capture the conditions of the soil, environmental conditions, and so on. Because these processes are very unique of the regions and are not very generalizable. So that's also something else to take into account. The problem, or the new challenge, I guess, is that there's not a lot of information from different parts of the world. I mean, if we focus just in South America, in the part that is near to the Pacific Ocean, there's not a lot of cases where you can gather information and train a very complete model. So I guess one has to make a lot of assumptions in that case. But again, it's a very complex problem, and that's why it's interesting.
Yeah. So earthquakes being relatively rare and also very geography dependent means that creating a large data set is always going to be really challenging. And I guess, Daniele, this is something that's going to go back to you when you think about taking this further. And it's kind of interesting to me that the detection side of it is really straightforward, albeit within the kind of context of, before and after quite limited time zones. But yeah, you did originally have plans to regress the location of the epicenter, right?
Yeah, still, I'm working with this right now, I will say, in these months, I will say. So I think in this case, it's like different from what I've seen and from what you can see. Because, with this type of product, is like ground range detected. So yeah, as you mentioned before by Giorgio, it's quite strange because, it's ground range detected. So, but some samples are literally quite in the sea, but probably because there is, some sort of little land. And so the satellite says, yeah, okay, there is some, ground, but not true. So when you collect them, you simply trust the Copernicus, I would say, system. And yes, if they tell you that this, we say, product is working with ground, you stick with, okay, it's ground in some way, but yeah, for sure it's not ground in this case. So you can clean the collection. I would say there are also some, samples on the ground, because not everything is like on the sea. So now I've tried to work with, some other type of data of Sentinel-1 is like SLC, so the complex one. So in this case, you can simply try to process them to get the interferogram. So people stick with interferogram right now. And generally, you can see they provide some interference. So you can try to understand at least in a different way, because the problem is that, as you mentioned, probably also by Giorgio, is that this type of data, like GRD, has not, I would say, many things that are not independent, I would say, of the place and other things like that. Well, for example, if you search for SLC, and also if you search for people that doing this, I would say, by hand, they get, I would say, like sort of cleaned, I would say, phase map. So you get, imagine a simple matrix with the information about the phase in each point. So it's different. I don't really know also in this case as before, I mean, if some sort of model could get something, but at least you can see in, I would say, in a large area where an earthquake happened, if there are some circles, or if there are some sort of, like, I would say, some sort of walls of interference. So you can try to do more a different analysis. It's quite agnostic, since in this case you simply plot, instead of the value on the range of the before and the after, you have a phase information that in that specific, I would say, products, like GRD, you simply lose because they kept only the amplitude. So you have another information that's probably also something that, as Giorgio mentioned before, could be useful also because probably there are some missing information. I have tried also to include other information like, tectonic plates and also the soil information, but still I do not get nothing better, I would say, after this insight, because the point is now understand how you can process these type of data that are quite, complex also for human. And also the problem that I've also noticed is like the inaccuracies. Geophysics is quite complex. So also the information that you have about, the epicenter, the magnitude, etc., have sometimes quite a large error, I would say. Depends on the event, I would say. So it's sometimes difficult also to say, you have to regress this point, you have to regress, I would say, this strength. It's not easy. Also, if you search for different companies or different institutions that do this type of annotation, they don't agree. Literally, they do not agree easily. So that's difficult also in this case, because I've seen other people right now that are working on this, like building damaged buildings for earthquake, etc. There are, I would say, many things that you cannot do anything for earthquakes to prevent them. They simply happen. You can try to simply understand how to recover and how to make people simply leave the places. So for sure, I would say, as Giorgio mentioned, it's like an interesting way to investigate how we can help, I would say, in this case, because you cannot prevent, like, in the case of wildfire, you can simply try to prevent the wildfire, but in this case you cannot prevent an earthquake. They happen. So you have to do something, I would say. You cannot simply say, as people pay attention to do not leave, I would say, something in the forest.
So what do you think is next for the solution that Giorgio's developed?
So from my side, also from what other people have done, I would say that is interesting, as I mentioned before, to know that things. So I hope that people I would say, I provided all the data that I have. So where they happen, and when, and also the data itself. So if you can try to simply subsample them, try to collect a time series, try to, do other things. So like I've done, say, try to collect some information from tectonics, from, other information. So, as Giorgio mentioned, probably also I would say, like a first evaluation that could be done that is, I would say, more easily understandable is like if we can really detect if an area was affected by a change or an earthquake, because they are different. As Giorgio mentioned, the first thing is like simply aggregate some data set from wildfire, for example, or from other changes, like also, I would say, like crop changes. So, and try to understand if we could discriminate between changes due to a shake of the ground or a simply wildfire that burned everything or some other event. That could be easily done, I would say, because in this case, in this evaluation, I would say it's not complete because, you have some non-earthquakes, some earthquakes, but probably it could be more interesting for people to know if we could discriminate these type of changes. I mean, this is more feasible, generally speaking, without too much effort, I would say. If you not get, I would say, any results, probably it's more difficult than, you can thought, but at least it's better to give it a shot.
Yeah, so it sounds like we can be looking forward to the next generation of this competition focused on that particular task, bringing in other metadata and other sources of imagery, potentially. To close, I'd like to hand it over to you, Giorgio, just to hear a bit more about what you learned during this competition.
I guess it's related to what Daniele said about discriminating between changes. I guess I learned that it is not very easy to see the patterns of an earthquake. I mean, when one imagine how an earthquake propagates, that's usually related to what's happening underground. I mean, some kind of lines or waves that move in circles, something like that. But it really depends on the type of, as I said, the type of soil, but also if it's an urban area that is covered in asphalt, you can't directly see. Even if there are effects or changes, you can't see them. So related to what Daniele just said about first classifying change detections that correspond to crop changes or urban changes or something like that, what I imagine that would be feasible would be like a hierarchical classification. So first, the easy type of detection would be crop change or something like that, then move to fires, move to that kind of thing, and classify all those changes with some kind of uncertainty prediction intervals, for example. That will be interesting to see. And having a map with these different type of changes in different regions of a city or an area will be something very useful to give to the authorities, for example, to plan accordingly. I guess that'll be interesting. It's not exactly my research area, but I think what I've done in the past related to remote sensing makes me think that's possible, and again, interesting. It's an open problem, and I'm all about open problems, I guess.
Fantastic. Well, thank you for sharing your insights and your solution to the competition. I agree. I think that there's very exciting potential for these technologies, and hopefully this will feed through into early warning systems and greater insights for governments and local authorities. Once again, thank you both for joining me, and I look forward to hearing about the next competition.